Good morning. This lesson is for my Honors Integrated 1 class. This is 13.3, but before I get started, I want to say I hope that everybody is doing okay out there. So let's go ahead and jump in for our 13.3 lesson and talk about our two goals. Our first goal is going to be to create a system of equations in standard form that represent a situation. The second thing is we're going to do the same thing, but with a system of linear inequalities. We're going to be setting these up in standard form, and I want to remind you something about standard form. Remember, in standard form, two things add to a third. It helps to figure out the total value and work backwards from there. The total value is what's being added to. Okay, so we can identify that number, then we can kind of reverse engineer our equations and create our equations in standard form. Let me quickly remind you what standard form equations look like. It's ax plus by is equal to c. That would be an example of an equation that is in standard form where two things are adding up to a third. And so I'm going to jump into our first goal. Our first goal, again, is we're going to create a system in standard form that represent a situation. So what I'm going to look for is I'm going to look for total amounts. So you're a member of one gym for a part of a year and switch to a cheaper gym for the rest of the year. The first gym costs $80 a month and the second costs $45. So it makes sense that you change gyms. You're saving yourself $35 a month. You paid $645 for the entire year. So in looking at this, I want to identify the amounts that are totals. And to me, this one's standing out pretty clearly. So one equation is going to have to equal to 645. I know that. But again, remember, we're setting up a system of equations, and I only have one total here. Now the other total, and I'm going to, you might want to hit pause and see if you can figure it out. The other total is a little subtle. It's hidden in the weeds, we would say. So the other total here is the time that you spent at the gyms, either the first gym or the second gym. Now, I'm going to say that this is equal to 12, right? I'm not going to say it's equal to 1. I'm going to say it's equal to 12 because if I said it equal to 1, then it's not so clear how many months I spent at one gym and how many months I spent at another gym. But if I talk about the total value, the third value being 12, then we can reverse create the equation. And so I know that I spent part of the year at one gym and I switched to a cheaper gym for the rest of the year. So I would create a little equation like this. X plus y is equal to 12. Where x is how long I spent at the first gym, and y is how long I spent at the second gym. And these two time amounts add up to a year. Now, I can now create an equation that's in standard form that represents the amount I spent. I spent a certain amount at my first gym, and I spent another amount at my second gym, and these two amounts in total add up to 645. So I know that this one, and I don't know how many months I spent, but I know that this gym was costing me $80 a month. So this is going to be 80x. This is how much I spent at my first gym based on that number of months. Plus 45y. This is how much I spent at the second gym for that amount of time. And these two amounts, the first gym and the second gym, they add up to 645. Now we would go ahead and solve this as we solved them before, where you would actually, multiply one equation maybe by negative 80 and then add them together and then solve for your y, or multiply them by negative 45, add them together, solve for x, and we would go ahead and continue that. So again, hopefully this makes sense on the first goal. I'm going to check that off again. Remember, I created a system of equations in standard form that represent a situation, and I found what my equations added to, and I worked backwards. Again, the first equation is about time. I spent 12 months at a gym, a certain amount of months at the first gym, and then the remaining part of the year at the second gym, okay? And then the second equation was about how much I spent in total for the full year. So this is how much I spent at the first gym, plus how much I spent at the second gym, and these two add to how much I spent in total. Again, remember, two things add to the third, and so hopefully this is making sense. I'm going to erase the board and create the second goal so you don't have to watch me write and erase. So I'll be back. I'm back. All right, so we're moving on to the second goal, and remember we were setting up equations in standard form, so we wanted to find total amounts, and we're going to do, in the second goal, we're going to be doing what we did in the first goal, but we're going to be setting up with systems of linear inequality. So we're not going to be using equal signs. We're going to have to use less than or equal, or greater than or equal to. But again, I want to look at this little story, and I want to find the numbers that represent totals. And once I know the numbers that represent totals, I can reverse engineer the inequalities to write, okay? All right, so you're buying shirts and hats as gifts. You plan to buy at least 8 gifts. That's a total number. And you spend no more than $120. That's another total number. So I know very quickly what my totals are, all right? So again, you're buying shirts and hats as gifts. You plan to buy at least 8 gifts and spend no more than $120. Hats are $10 and shirts are $15. Okay, so we're going to write two inequalities in standard form using the totals. So I know that I'm going to buy at least 8 gifts. And my gifts are shirts and hats. You can say that, S is the number of shirts plus H is the number of hats. Now this was in an equation, we just set them equal. But we plan on buying at least 8 gifts. And if I'm going to buy at least 8 gifts, that means I'm going to buy more than 8. So I'm going to be using this inequality symbol. Okay. My second inequality, my total is going to be 120 degrees. $120, 120 degrees. That's a trig number that I'm teaching right now, but it's $120. So you're going to spend no more than $120. Okay? And so we're spending money on 2 items. We're spending money on shirts and we're spending money on hats. Shirts are $15, so I'm going to say 15 times S, that's how much I'm spending on shirts, and I'm going to say 10 times H, that's how much I'm spending on hats, but I'm not spending more than $120, so this side has to stay below the $120 mark. And so remember, when we do solve inequalities, you're solving the graph. You're looking for where they overlap. Okay. So again, hopefully this makes sense. The first inequality is about the number of items that you're buying, and it's going to be more than, or at least 8, right? You're buying shirts and hats, and however many shirts you buy at $15 a shirt, that's how much you spend on shirts, and however many hats you buy at $10 a hat, that's how much you spend on hats, and these two amounts have to stay less than $120. That's the total amount. And again, remember, we do graph inequalities, and we find where the shading overlaps, and that's the solution. So there's going to be multiple possibilities for this. So hopefully this makes sense on how to solve. That's going to be the end of the lesson. Have a good day, everybody. Bye-bye.